We'll begin the discussion here on biological evolution today in this video, and I just want to make it clear the reason that we're discussing biological evolution is to let us know that this is a cultural psychology course, that human beings share like 99 plus percent of their genetic material. We are a product of a long history. And these cultural differences that we're talking about, they may even go back to the ancient philosophers, but ultimately, the cultural differences that we see are relatively recent in human history if you take the long view. Okay, so we want to start with this idea that we are fundamentally the same, and then some cultural differences will emerge. Okay, so let's start real basically the basics of evolution, and let you know right from the beginning, and I'll expand a little bit on this, that evolution is not just a biological theory, it is also a psychological thing. That is, evolution can select for things like the tail of a monkey or something like that, but it can also select for behaviors, right? Behavioral processes, timidness, for example, or bravery. I don't know, all kinds of things it's going to select for. Okay, so briefly, I want you to spend a little bit here and actually read this disclaimer, but let you know that I'm not going to force you to believe in no biological evolution. That's your choice. But you want to go out and say, I have a diploma, look at me, I'm educated. And you don't have to believe it, but you have to understand it. Okay? You have to have an understanding of the processes of evolution, even if you don't fundamentally believe them, because the processes of evolution form the core of so much in biology, chemistry, psychology, sociology. Many of these disciplines just don't even make sense if you don't start with evolution as a foundational principle. Okay, so you take a look at it, please, with be skeptical. I'm fine. I mean, that's what's a good scientist is in fact skeptical, but they're not closed-minded. Okay. No, before Darwin came around and became famous for what he invented, whatever, there was lots of things that are around. Like Thomas Malthus, who was a social philosopher, actually, he was writing about how many poor people were living in the slums in the cities. This is the kind of things he was referring to. And so he referred to this idea that food supplies or production of food tends to increase mathematically, and that is that straight line there, production of food. But populations of organisms tend to increase more of a geometric form. That is the population curve. And what happens is at that crossing point, you have a catastrophe or something. So once you've crossed that point there's going to be a struggle for survival. There's going to be more organisms around than there is food supplies to support them. And there will always be animals dying. Okay. And this is going to form the basis of much of evolution, because it's like, who decides who dies? Somebody's going to die. Take a look at this. It's going to happen. Who decides? And so as we move forward, we'll find that natural selection, nature decides who dies. Artificial selection, humans decide who lives and dies. Sexual selection, women decide who lives and dies. I mean, there's a lot of answers to this question, but fundamentally, that's what Thomas Malthus lays out here. Charles Darwin also, while he was on his voyage on the Beagle, his famous voyage on the Beagle, he actually wrote his first manuscript while he's on that voyage, and it was on the variability in barnacles. These are barnacles, and these are just like on the bottom of the boat, and he was intrigued by how much variability there was in something as primitive and simple as a barnacle. And so he noticed, in the same way that there's variability among humans, some are taller, some are shorter, some are wider, some are thinner, all these variability things, all populations have these types of variabilities. Okay, so he discovered this even before he laid out his theory. Another thing that tends to, well, I don't guess I don't have that slide here, but another thing that he knew, though he didn't know why, he clearly fell short. He knew that babies tend to look like mom and dad. Tend. There's a tendency. Okay, so organisms are going to die, There's variability in any population, and babies tend to look like mom and dad. And so the idea here is evolution is, by definition, the change in the average characteristics of a population across time, okay? Or whatever these words are, same idea. And so, in some kind of a way, evolution is just a statement of fact. I mean, organisms change. That is not controversial. It isn't. I mean, take a look at the left side. You've got a sloth. That is a sloth that lives down in South and Central America today. It's like the size of a dog, something like that. Hangs up in trees. On the right side is a sloth from 10,000, 12,000 years ago during the last ice age. And it's, bigger than, 12, 15 feet tall. So it's pretty clear animals change. That's just, animals do change. Evolution is a change in the average characteristics of a species. Okay, great. The average sloth is the size of a dog. The average sloth used to be 12 feet tall. They change. It's a theory, however. Evolution is a theory because the question is what exactly is causing these changes to occur? And it's an ongoing. It is a theory in this still. It's an ongoing story because it's very complicated. Now, what we find is that even before Darwin, everybody knew evolution happened. In other words, organisms change across time, and there was already some tentative attempts to try to explain why they change. In fact, Jean Lamarck had the very first explanation on inheritance of acquired characteristics, and so he argues, there's a blacksmith, and he works very hard, and he builds up big muscles, and then when he has a son, his son tends to be born with those big muscles, inherits those big muscles. Because babies tend to look like mom and dad, okay? And in retrospect, it seems a little silly when you look at this because somebody becomes a blacksmith because they're relatively tough. Because they're relatively tough, their sons will probably also be relatively tough. Okay, but it's an explanation. Okay? What Darwin was most famous for was this particular explanation for, why or how evolution occurs. Nature selects. Nature selects who lives and dies. And so going back to this notion that there's some variability in every population of organisms, certain variations on the organism are adaptive and certain ones aren't. So on the left side, we've got a pepper moth here. That's what the average pepper moth looked like during the Industrial Revolution. Clearly, there's some variability in the pepper moths, and some would be very light colored and very dark colored. And it turns out if you've got a pepper moth that's pretty much white, when it lands on a tree, it sticks out like a sore thumb and birds eat it. And if a pepper moth is dark, more like a black, it lands on a tree, it sticks out like a sore thumb and birds eat it. And therefore, the average pepper moth, well, that is to say, nature selects who lives and dies. Nature selects and says, white pepper moths and black pepper moths will get eaten. During the Industrial Revolution, and the trees got real dark and black with coal soot and all this nasty stuff. Then all of a sudden, that average pepper moth that we see on the left, all of a sudden when it lands on a dark colored tree, it sticks out like a sore thumb. And so which pepper moths are now more likely to survive? The darkest ones. And so nature selected who lived and who died, and babies tend to look like mom and dad, and therefore the black pepper moth, when it has babies, tends to have dark babies. Okay? And then after the Industrial Revolution, when the trees went back to the colors that they're supposed to be, the pepper moths flipped right back to where they had been before the Industrial Revolution. Okay? So pretty powerful. But as I said, there are many, many, many mechanisms for evolutionary change, far more than I would be willing to discuss in a cultural psychology course. But two of them, basically sexual selection, that females tend to choose who they mate with, and females tend to prefer pretty boys, And so we find all kinds of strange things happening in the world of animals. All right. And in the world of humans, by the way, because blue eyes is a genetic, it's a, it's not good. Blue eyes is a mutation that if somebody has blue eyes, that means they do not have the pigmentation in it. So when you see blue, you just see the blood in the back of the eyeballs. That's all that blue is. And so what happens is people with blue eyes are at a much higher risk of developing eye cancers, right? They don't have the protective melatonins in there. And so what happens is that by the principles of natural selection, blue eyes should not exist, okay? It should not. But since girls tend to choose who they mate with, and girls like pretty boys, and girls tend to prefer blue eyes for some odd reason, therefore, blue eyes has in fact remained in the population despite natural selection saying it ought to be gone, okay? And then human beings have been in charge of much of evolutionary change by selecting for things that we prefer, whether it be, cows that give more milk or goldfish that are pretty. We choose these things.